Today we're going to be talking of the Dragflow Amphibious Dredges and let's say what these solutions do for these particular problems. Okay. So without further ado, let's just dive into it. Today's agenda is contains a brief introduction of the company. It's just a really 2-minute introduction on the type of solutions that we provide for our customers. Then we will dive deeper into what the amphibious dredgers are on the second segment of the webinar. Then we will cover some case studies and previous applications, and at the end we will have a Q&A section for any questions you might have. So for those who don't know, there is a Q&A section in Zoom that you will find right next to the Zoom options, where you can write all your questions and we will reply all of them at the end of the presentation. In any case, all of the questions will also be forwarded via mail to all the participants so they can have all the answers on your queries. So on this brief introduction of the company I wanted to make, Dragflow is a company that specializes in the manufacture of dredging equipment. Okay, this goes from it's basically centered around submersible dredging pumps. Okay, so yeah, we're a manufacturer of submersible dredging pumps and also of complete dredging systems. Depending on the application, change from one to another. So we have the amphibious systems, we have remote control systems, and we'll see a bit more detail on one of those today. As a brief, to put it in small words, a few lines, what we do to help our customers is provide solutions for sediment management, where it's accumulation of sediments in a port, in a channel, or a river, whether it's loss of capacity in sedimentation tanks, in industrial processes. Also in mineral applications, we have tailings reclamation and, well, any other type of sediment management inside the mines, and also cleaning of hydroelectrical dams, which are characterized by large dams. So what we do is provide solutions for all of these projects, and regardless of the site conditions, whether it's a shallow water application or a very deep applications, we can find a solution that fits the project. We divide these solutions into 4 main groups. Okay, the first one would be the dredging pump itself, which is going to be the heart of the dredge. The submersible dredging pumps can be either electric driven or hydraulic driven, depending on the application, and they can go from 100 to 4,000 cubic meters per hour of mixture. Okay. Then we have a first type of dredge, which would be the cable dredgers. Just 1 second, seems to be a problem with the sound. Maybe this.
I think this will help. Okay, let's continue and see if it improves. So on the first type of dredge we have is a cable dredge, in which what we have is a submersible pump suspended on a steel cable and then lowered directly into the material. Okay, so this would be the first type of dredge that we have in our range. Then we have something much smaller than that, in which, in this case, it's a similar construction in which the pump is suspended from a steel cable, but it's a remote control dredge. So there is no operators on board, there is no cabin, and there is no power unit on board. So it's a very, very compact machine, especially designed for, let's say, corrosive applications or dangerous applications in general. And then we have, let's say, the subject of the matter today, which would be the amphibious dredgers. This, by the name, of course, is machines for shallow water applications where it is very difficult to use any other type of dredging technology. So this is what we're going to be talking about today in a bit more depth. Just to mention a couple of the different industries or fields of application that we work in, we have divided them in 5 major ones. We have industrial applications for, say, the cleaning of paper mills, steel mills, thermal power plants for the intake of the water, any type of applications inside the industry. So any sedimentation pond in the process. Then we have more conventional dredging applications, which include the dredging of hydroelectrical dams, ports, rivers, or lakes. We have offshore applications, which refer to applications having more than 100 meters of depth. We have the sand and gravel division, which is, let's say, extraction of material for commercial purposes. And then we have the mining applications, which involve mostly tailings reclamation and sediment management inside the mines. Let's go a bit more deeper into the amphibious machines themselves. So we have 2 main series here in Dragflow, the DRM on the left side and the DRSP on the right side. Looking a bit more detail into this machine, just to give you this small video, just to give you an overview of the machine, then we will go into detail into the components. So as you can see, this is a tracked machine, similar to a standard amphibious excavator, but very different at the same time. And the main difference comes from the presence of that central floater that you saw at the start of the video that we can see here holding the whole structure together. So it has 2 side floaters that are equipped with these tracks that are made in polyethylene, so they don't destroy the floor under it. And we have a dredging pump suspended on the hydraulic arm of the dredge. Okay, so this would be the overall construction of the dredge. The large spots that you see on the sides are used for stabilizing the dredge once it has to, let's say, maintain a position during the dredging operation. Here we can see, well, a good overview of the machine with the 2 tracks, the spots, the hydraulic arm, the dredging pump, and the operator cabin with hydraulic power pack in the back. So it's a machine designed for shallow water applications. Any place where there's very low depth of water, where we have to, it would be difficult to put a floating structure. This is where these machines can come in and help. So in terms of some numbers, this machine has an installed power of 260 kilowatt, and the motor, the diesel engine, will drive hydraulically all the other components on the dredge. We have a maximum dredging depth of 6.5 meters with the arm. Okay, this would be the maximum dredging depth that can be achieved with this machine. And it is also possible to remove the dredging pump and use other hydraulic tools like hammers or pile drivers or buckets or rakes. So it's a very versatile machine for those projects requiring, say, the nourishment of a river, where there are many types of work to be done in one single project. So as a general arrangement of the dredge, we have the 2 lateral side floaters with the tracks. We have the hydraulic arm with the dredging pump at the tip, the hydraulic power pack located in the back that powers all the equipment in the dredge, and the operator cabin for 1 person. This is a 1-person machine. So then we have on position number 5, the stabilizer spots that we were mentioning before for fixing the dredge in position. A hydraulic propeller located in the back of the dredge that can, let's say, will move the dredge from point A to point B in a really fast. Let's say it would is to change dredging position. Say once we are done dredging a certain area, this will help us move faster to a new dredging area. okay? And in the case that there is a strong current in a river, for example, we also have 4 winches on board that can be used for anchoring either to dead weights or to some anchoring points located on the shore. So this is also to help the dredge stay in position in presence of current. This is a video to show just that hydraulic propeller working in the back. It's a completely autonomous machine, as you can see, and it can go on land with the tracks and in the water with its own propeller. So it's a very easy to adapt to different projects. The inside of the hydraulic power pack that was located behind the cabin is well composed by a diesel engine and a hydraulic block mounted directly on the diesel engine shaft. So since this is all made by Dragflow, we can also customize it and add any type of appliance that we need from the hydraulic power pack. So this can be designed as a custom unit. And for standalone pumps, it can also be supplied as a standalone power pack. So it can also be supplied, let's say, together with just a pump. The undercarriages of the DRM amphibious dredge are particularly different from standard excavators that use multiple links for the same soles. In our case, we have independent links for each sole, which makes for a much faster maintenance when these get damaged. Now, just to address the main issue here is what would be the difference between this dredge and a common or standard amphibious excavator? And to put these 2 extremes here, I would like to mention that the main issue would be flotation and stability. Standard amphibious excavators are composed of 2 lateral floaters and just a set of links that join them together. This set of links also support the cabin of the excavator that you see here. So having this setup and such a long arm in some cases, moving in certain directions could cause some stability or flotation issues in this pontoon. So what we did in this case, this is an issue most contractors are familiar with. And what we did in this case is we mixed together what will be the design of our dredgers with the amphibious excavator idea. So what we have here is the 2 lateral pontoons and a robust central hull to guarantee that dredge stability. So we can mix the best of both worlds here. We can have the mobility of an amphibious excavator with the stability of a full floating dredge. Now, in terms of production, which is of course the most important thing in a project, we have 2 versions that we can use in this dredge. We have a long distance version, that you can see here on the left, with a maximum capacity of 500 cubic meters per hour of mixture. Okay, we can pump this mixture at a distance of 1.5 kilometers. On the other hand, if we would like to increase our flow, we also have the high capacity version, which allows us to pump up to 800 cubic meters per hour and at a distance slightly lower, but of 1 kilometer from the dredge, without any booster station, of course. This would be the pump that would be attached to the arm of the dredge. And depending on the project, they can also be exchanged. They're interchangeable. So if we have a long distance applications, we can use one. And if we want to increase production because we are closer to the shore, then we can use the high capacity version. Okay, so that would be the first amphibious dredge that we saw, okay, the DRM with the tracked hulls. Let's talk now a bit about this new DRSP dredge. This is actually the first one we're delivering for a customer in Switzerland. This is for a regulation dam in a hydropower dam. So this is the first lake that receives the water from the rivers and that keeps the sediment before the water is passed to the main reservoir of water. So this is it's a large sedimentation pond where they will be using this machine. Again, just to give you an overview the machine. So we have here some better videos of the one that's being supplied right now. So this is a very different machine from what we just saw. This one does not have any tracked holes, but it can still move itself over the terrain. So looking from right to left, we have the dredging pump on the tip of the hydraulic arm. We have a hydraulic arm that allows us to reach the 6.5 meters of working depth. Again, same as the other dredge. We have the operator cabin, hydraulic power pack in the back, and a set of stabilizer spots in the back and 2 in the front. So how does this machine move itself? What it does is these pillars here, they can be inclined, and actually when they're lower, they can push the dredge forward. So when these spots will get into the inclined position, like you can see here, once they are lower, they can push the soil and then therefore push the dredge forward. So let's see a bit more detail, some of the numbers and specs of this machine. Like I said, this is a different approach. This machine has a lower mobility than the dredge that we saw before, but it has a much wider working area because we have a much wider swing of the hydraulic arm in this case. Okay, so while the other dredge can move really fast from one place to another and therefore dredge many places in a short period of time, this dredge can stay in one position and dredge for longer periods of time before it has to be moved. Okay, that would be the main difference between the two systems. Like I said, we still have a 6.5 meter maximum working depth limited by the length of the arm. And we can also change here, let's say what would be the dredging pump into some other hydraulic tool like a rake or hydraulic hammers or pile drivers. So here is, well, just to show the different attachments that we can use. Again, this is a great solution for river restoration projects where we have to do different types of jobs. It is therefore necessary to have a wide variety of tools to use. Like I said, we have a much larger working area with this dredge, and this allows us to stay in one position for a longer period of time. We have much more volume to take out before we change the position of the dredge. Some of the components here, just as we saw, we have the rear stabilizers, which once they get inclined, they can push the dredge over the material forward. We have the operator cabin, the hydraulic arm with the dredging pump, the pipeline that goes all the way to the back of the dredge, the front stabilizers, and 2 side floats that you can see here. So this dredge is composed of 3 main parts. We have the central hull, which is pretty much the entire system, and then just these 2 additional floaters for let's say higher depth applications. When the machine will be fully floating, that's when we have to use these 2 floaters. Here we have just the top view of the dredge in which we can see the back of the dredge. Let's see a bit more detail right here. There is also a hydraulic propeller in this dredge. So if we are in deep water applications, let's say up to 6.5 meters, we can still navigate independently from one place to the other. We can go backward, forward. And what's more is that we can regulate the position of this propeller depending on the site conditions. So it's an independent machine, and it still has the possibility to move both on land and on water. Okay, so here's some more pictures of some of those elements. We have the propeller here, the 2 spots in the back with the hydraulic cylinder for the inclination. We have a hydraulic power pack feeding all the components, the cabin, and well, the front of the dredge, which would be here. We have the hydraulic arm and the dredging pump at the tip. Here's, well, some pictures of the inside of the cabin. This is again a 1-person machine, and here you have all the controls of the working depth of the pump. We can have flow meters and density meters to tell the operator how much material is coming out, GPS and bathymetric systems as well. So it's a very complete display of the information that the operator has at the reach of his hand. Another important feature of this dredge is the fact that it can load itself into a truck bed, okay? By taking out the side floaters, the dredge can lift itself using the stabilizers, and then a truck bed can be slid down inside under the dredge. So the dredge goes up and the truck bed gets slid inside. This would be the next step of the amphibious dredgers. Okay, so what we're trying to do here is make a combination of what we had before. Let's say we have the tracked amphibious machine with that we saw the first machine we saw, and then we had this other one without tracks. This next step, which is still in development, is a combination of the two. So we will have our on-track dredge with this particular upgrade we can use if the project requires. So maybe a project requires a certain degree of mobility that doesn't need a track machine. And then maybe further on, this can be added as a second step. So this would be the future of the amphibious dredgers here in Dragflow. Just to talk about the capacities of the pump as well, we have the long distance version, which is the same as before, 500 cubic meters per hour at 1.5 kilometers. And then the high capacity version at 800 cubic meters per hour at 1 kilometer. Okay, now we spoke about the dredgers. Let's talk about something the dredgers have in common, which would be the dredging pump. Okay, this is the heart, and this is what takes the material out. So it's important to share a few notes on how this is different from what's out there. So the Dragflow pumps have an open suction right in front of the material. That would be the first thing to point out. The point that we have the suction right in front of the material means there is no suction pipe, and we have complete control of what is going on, what is going inside the pump. Okay, so you can see in the picture, there's an agitator integrated to the shaft, and as it rotates, it will create a flow of water that will put all this material in suspension. Okay, once we put that together with maybe other types of cutting mechanisms, we have really high solid concentrations, which is what really characterizes the submersible pumps. So the fact that we have full control of what's in front of the pump is what gives us this 70% by weight concentrations that we can achieve with the Dragflow pumps. If we had a suction pipe, then the story would be a bit different. What it means to have higher solid concentrations in the mixture is that we can even use, we will use smaller power units. We will consume less diesel. We will have smaller pipelines for the same production. And what this means is all just lower cost per cubic meter of material that is extracted. So it will make a long difference in a project. Here's just a video to show you the effect of the agitator. This is an electric pump working. It's the same operation for all the Dragflow pumps. We have the agitator that as it rotates, it will create that flow and lift the sand in the bottom. Okay, so maintaining that cloud around the suction of the pump is what's going to give us that higher concentration through the entire process. There's no additional cutting mechanisms here. This is just the agitator working on its own in a loose sand application. Okay. We will share these videos on a link for everybody that was here in the webinar, so you can check them out if you want. If you want for your records, we will have a link for all of these videos. You can download them or stream them online. Besides the agitator itself, there's also two options of cutting mechanisms that we can add to the pump. These are mechanical cutters, okay? So the first version would be a more conventional dredging cutter, which resembles a cutter suction dredge and is located right in front of the suction of the pump. So what we have here is a hydraulic motor for the cutter head and a hydraulic motor for the pump. Okay, so everything is fed from the hydraulic power pack of the dredge. This could also be mounted on a standard excavator. I mean, on any excavator, we can use the auxiliary systems and feed a dredging unit. So we can turn pretty much any excavator into a fully operational dredging machine. The other option would be the side cutters, which were actually the first type of cutter we designed in Dragflow. And as you can see here, we have two cutters placed on the side of the pump that rotate in opposite directions and not only cut the material, but also bring it to the center and the suction of the pump. So once that happens and the agitator mixes all that, we have a very high solid concentration in front of the pump. And this is what I meant by having full control of what's happening there. In the case, let's say in some mining applications, this is actually quite necessary, let's say, or in any applications where we have finely grained material, like like a clay or lime or mining tailings, we have to dilute this material. It will not be enough just to cut through the material because it will still be, let's say, a big ball of solids. So what we do in this case is we add a jetting system, which pretty much injects high pressure water into this frame mounted on the pump. So the water flow is going to be dependent on the pump flow, and the pressure is usually kept between 6 and 8 bars. So like I said, this is special for dealing with sticky materials and finely grained solids. All right, so we saw the two types of dredgers. We saw what the companies was about. We saw the type of solutions that we make. Let's dive into some of the past projects so we can see how these machines have been used before. So the first example is a copper tailings reclamation project in Panama in 2018. So in this particular project, the mine had different tailing dams spread all over the mine itself. So they needed a solution that could go into the shallow water areas, dredge material out, and then quickly move into the next dredging zone. So a machine that could both go on earth and on water was the preferred solution. In this case, well, our standard amphibious excavator with the tracked hulls was supplied because they could easily just roll into a certain tailings pond, dredge some of the material out, and then roll out into the next area of the mine. So this way they could cover all of those ponds that needed dredging. Here's the undercarriage itself of the dredge, and this, as you can see, it's a very robust machine, and it's a very robust undercarriage specifically for what we spoke about before. We spoke about flotation and stability, and this would be, let's say, the difference maker in the project. Another project in Chile. This is also a copper reclamation project for tailings. As you can see here, the application is much different. This is a much drier place. The tailing dam was really large and with very low water quantity. So again, it was impossible to use floating dredgers in this case. So this was actually the first amphibious machine we ever did. And well, we supplied it to the customer, and it allowed them to retrieve the tailings at a concentration good enough that it could be sent straight into the plant again for reprocessing. That was the purpose of the project. They were reclaiming the tailings for further extraction of the material. Here's a couple of pictures and the video. See, in the video you can see, well, this is the test that we do before, well, during the commissioning, before the connection of the pipeline. And this is just to test, to see the pump of the flow of the pump. And then we have here a detail of what the dredging unit was. We had the dredging pump with the two side cutters and the jetting frame that you can see here especially because the copper tailings are usually very fine in grain size. Then we have this other project. This is a more conventional dredging project. This is the Rio Magdalena project in Colombia. This is a project that is actually supposed to take about 15 years in completion, as it contains about 900 kilometers of river to be dredged. So it's a very shallow river in some areas. And as you can see here in the picture, there are some small islands. Some of those islands had to be completely dredged out as the river was supposed to regain some of its navigability. So they needed a quick machine to go in and out of the river and go to these shallow water applications. Here we can see during the startup, as we were doing one of the put in water of the dredge, to put it that way. It's just to show how easy it was to dive in and get out of the dredging area. Like we saw, we have the tracks for the earth, and then we have propellers for the water. So we can maintain the same mobility we have right now, even when we're in the water. Okay. This is after the startup, we have the startup team and the two machines that we supplied in this case. In this case, we had 2 amphibious dredgers working on deeper areas of the river. And then we have 6 standard excavators working with dredging pumps attached to the arm that they would work on, say, the shoreline of the river itself. And this last case history is actually our most recent project. This was in the Philippines in 2019. This is actually a pretty big project as it involves many different types of dredging technologies working together to make it happen. So this is the restoration of the Manila Bay shoreline, and it involves deep water dredging, shallow water dredging, and anything in between. So in this case, we have cutter suction dredgers working in the deeper areas, let's say in the port or other navigational areas. And then we have this, the Dragflow DRM working in the shallow areas along the shore. So this really completed the range of solutions needed for the project. This is just one of the videos during the startup. Right on the beach. And this is the startup team once the machine was completely assembled and commissioned to the customer. So that's the introduction I wanted to do for you today on the amphibious dredgers. Let's move into the Q&A section. If you have any questions, please remember to use the Q&A section that you will find right next to the Zoom options where you can use your phone or start your video. So you can write your questions there, and we will reply them here in this next section. Okay. Let's see. We have a first question. The DRSP can reach a maximum depth of 6.5 meters and has a dredging area of 100 square meters in one set position. Let's see. Well, if we have actually a full drawing on the working area for different depths of this dredge, we can forward this to you together with the rest of the answer, so you can see, let's say, the working area we have at each meter of those 6.5 meters. Okay, so you can see what type of volume we can take out in a single position. Okay, so we'll make sure to include that in our full report. Okay, we have another question. What is the delivery time for the DRSP amphibious dredge? Well, this is usually, depending on the setup, it can be done either electrical or hydraulic. We're looking at a minimum of about 12 to 14 weeks from delivery. Again, this is based on availability of the major components and just to give you an idea of what to expect. We have the next question. Can we extend beyond 6.5 meters for the amphibious dredgers? Well, we can. We can actually, the system we have in mind is actually a combination of the cable dredgers and the amphibious dredgers. So what we would do is beyond those 6.5 meters, sorry, we can detach the pump from the arm and lower it with a cable vertically into the material. So this is a solution we're studying for putting together these two systems. Okay, so we detach the pump from the arm and lower it with a hoist into the material through a cable. So this would be the higher depth solution for the amphibious machine. Do all engines diesel fulfill Tier 5 emission stage? This is done on the phase of the order or of the selection or the sizing of the machine. We can definitely provide any type of tire requirements for the diesel engines. The next question we have is the long reach boom also available for these machines? Well, you see, that is where we put in compromise the stability of the dredge. Having a large boom means having a large momentum on the floating structure itself. So it wouldn't be suggested to have the long boom excavate, the long boom arm in this case. What we could suggest is what we were mentioning before about detaching the pump and have it go into the material. The cutters, like we saw, they rotate in opposite directions. So it is possible to keep the pump in position, even if it's only held by a steel cable. Okay, so this would be the combination of the two systems. Another question we have, the application of both types are almost the same. What are the main differences between the two? Well, I would say the main difference between both dredgers, it will come from the project itself. What I mean by that is, in this dredge, we have no tracks to roll over the material, so it will be slower for it to move over the material. But at the same time, we have a large working area in front of the dredge. Okay, so this would be the setup in this case. In the other case, we have a much faster machine that can change position just by rolling to a new position, but it has a more limited working area in it. So let's say for a project where we have to dredge here and then maybe let's say farther away a couple 100 meters, we can roll with our tracked machine, let's say with this one here. But if we have to transport the dredge for several kilometers, for example, it would be easier to have something modular like this, because this is only two bed trucks, okay? And the other machine would take 5 bed trucks. So this is a very simple machine to disassemble. It will move slower, but it has a much wider area and the possibility to transport it really fast. So this would be the main differences between the two. We have how can we apply part of this equipment if the client has his own excavator, such as a CAT 320? Well, the undercarriage itself of these machines would be hard to include on existing excavator, and that's just because of all of the other components we have here. What we could do with that excavator is, if possible, we can put this on a platform and have the dredging pump on the tip of the excavator, which is we saw is one of the solutions that they use in the project in Colombia. So like this way, any excavator, as long as it's on a platform of some sort, can become a dredge itself. And you have a solid production of solid from the pump, and you have the working area of the arm itself. So this would be the operative we could do on that excavator. Okay, so we don't have any more questions right now. I don't know if anybody has any questions. You can use the Q&A section. Otherwise, thank you very much for joining the webinar. This was the second webinar. The first one we covered the remote control dredgers, and this one we did the amphibious dredgers. Feel free to let us know if you'd like to see something more in particular, any particular application, dam dredging or fly ash, anything that comes into mind. So again, thank you everybody for being here. We have one more question. All right. Since there is no chance to increase the boom length, can we use the cutter as a rope dredger? Yeah, exactly. We can detach the pump and the cutter and lower it through a rope or a cable into the material. Okay, so this would be the combination. So we would use the boom for shallow water applications, and then we could detach that pump and lower it through a cable into the material. Other question we have, can we change attachments, just such a grabber, clamshell for pipe sets or dike preparation? Yes, it is possible to take the dredging pump off and install any hydraulic tool on board of the on the tip of the arm. So this can include a rake, buckets, grapples, clamshells, pile drivers, any type of hydraulic tool we can use for any job. And then we have the engine power is 265 kilowatt, pump cutter is 165 kilowatt. How much fuel do we need? Well, this is going to depend on how much we are pushing the machine, let's say different components we're using. We can include this answer on the set of answers that we'll be sharing, just to give you an idea of what the usual diesel consumption would be for a basic operation. All right. Maximum, what would be the maximum wave size or the maximum river current? Well, in the project in Colombia, the one that we saw here in the end, this actually had a pretty high current depending on the season. So in this case, we had a 3 meter per second current. And again, we had to use both the stabilizers and the winches to keep the dredge in position. That's why the winches are there for, to help the dredge, even in presence of current, to stay in position. But that would be a safe number to keep in mind in terms of current. Of course, if there's a particular request, we can try to study, let's say if we need to upgrade the winches or put a stronger anchoring system in place to manage that particular project. Okay, this could mean thicker spuds, thicker or bigger winches. There's a world of upgrades that we can do on the machine to make it fit.